Are you having problems with UART in noisy environments or over long distances? In this video I would like to try something out. I want to use same serial port on microcontrollers as usual, but add something between those micros to make it more suitable for longer distances and more immune to noise. I should be able to take already working system and extend the serial wires using my converter ports. No code changes should be required. These are transparent UART to RS485 converter PCBs. Transparent in a sense that the microcontroller doesn't need to know that the signal is converted to RS485 and back again in the other end. These are the PCBs designed by me and made by the sponsor of this video, PCBWay.com. PCBWay.com is an affordable PCB manufacturer who offers PCBs starting from just $5 plus shipping for 10 2-layer 100 by 100 mm PCBs. They are a great PCB manufacturer for all your prototyping and low volume production needs. If you need something else than just usual 2-layer boards with usual green solder mask, head over to PCBWay.com, check their capabilities and check out all the different options you have during the ordering process. So the RS485 is the keyword in this project. It defines the electrical characteristics which allow longer range and better noise immunity. Basically for RS485 there's a differential line, preferably a twisted pair, where there can be multiple drivers and receivers but only one can transmit at the time. The voltage threshold where the receiver detects 1 or 0 is super low. While the driver outputs couple of volts either positive or negative, the receiver has threshold of just 200 mV positive or negative depending on whether it's 1 or 0. With chips like MAX485 we are able to take the advantage of this RS485 in our projects using just about any microcontroller we want. But hold up, what's this thing about only one node being able to transmit at the time? That's right. Only one can transmit at the time, but node can disable the driver when it goes into receiving mode and then another one can transmit. In MAX485 there are DE and active low RE pins, driver enable and receiver enable. When transmitting, DE should be high and when receiving, RE should be low. It's not what I'm trying in this video, but if one was to design system with proper RS485, each node would control these pins. Often there is a main node which can send commands to other nodes and then turn off the driver in order to receive the possible response. Only the node that the command was directed to should react to it and enable the driver for transmitting the possible response, disabling it after the transmission is completed. But hold up again. That doesn't sound like something that could replace the usual UART without any code changes, doesn't it? After all, UART has dedicated RX and TX lines and data can flow in both of them at the same time. Some of you who have taken a look at this PCB might know how this can convert UART into RS485 without needing to control the DE and RE pins. This board actually has two MAX485 chips and two pairs of wires should be connected between two of these converters. One MAX485 has DE and RE pins hardwired to VCC, making it a transmitter, and another one has those pins grounded, making it a receiver. Both directions have their own twisted pair. Actually, even though I'm talking about RS485 and using MAX485 and board is named as such, I am using RS422. RS485 and RS422 have pretty similar specs, but RS422 has only one transmitter per line. It can have multiple receivers but only one transmitter. So technically this is a UART to RS422 converter. But this board was designed to illustrate the answer to how to convert UART to RS485 when I don't want to modify my software. Answer would be use RS422 instead of RS485. Here are two devices talking to each other using UART. Using short wires, that is just fine. But when one device needs to be in another room, another building or in a noisy environment, 2 jumper wires aren't going to do the trick anymore. In such case, I can take these modules, one on each end, and use a long cable with 2 twisted pairs. The communication between these 2 devices can now continue without any problems. There really isn't much to it when it comes to this circuit. Data from the microcontroller comes through the RX pin on the left. It goes to the top MAX485, which drives the 1 differential pair. Data from the remote device comes through the another differential pair, which has the termination resistor on board, to the bottom MAX485 that then spits out the data to the microcontroller through the TX pin on the left. Basically, there are 2 separate MAX485 converter circuits in this PCB. Very simple circuit, it does the job, I'm happy with it. Thanks for watching, maybe liking, subscribing. Thanks. Bye.